This is group 58, discussion for recitation 15.
All right, so this week's recitation is the last one we ever have to do. Thank God. It was only one problem. I had two parts to it, and yeah, let's just get into it. So the problem was about this system right here, where you have two blocks of different masses attached by a rope over a pulley, and then one's on an inclined plane and one is free to fall down to the ground. And then we're given these different variables and then asked to find or asked to solve for these different variables. And so with part one, it's asking us what is the acceleration of each block A. So I kind of did this in a roundabout way. So all the work is not like, well, all the work is here, but I'll just explain what I did for this. So right here, you have the torque principle where you have T2R minus T1R is equal to 1/2 mr squared times, this would be alpha, which we know is equal to A over R. So then if you factor out the R, you'd have T2 minus T1 is equal to MA over 2. And then as you can see, there's kind of this work right here. You might be confused, but if we go to part two, it asks us to find T1 and T2 in each portion of the string. And so we know that the net force on an object is going to be equal to the mass times its acceleration. So I basically just plugged in that T1 minus F minus M1G sine theta is equal to M1A. And then we see that our normal force is equal to M1G cosine theta. So then you can solve for T1 by rearranging this top equation, and you get this big long answer. T2 is a lot simpler because it's just hanging by the rope. So mg2 minus T2 is equal to M2A. So solve for T2 here again, you get M2G minus M2A. Take those two tensions, plug it back into the top, and then solve for A. Takes a lot of algebra. And then you get that A is equal to M2G minus MK M1G cosine theta minus M1G sine theta over M1 plus M2 plus M, big M over 2, where big M is the mass of this pulley. But yeah, that's basically the way that I did that, and it's just one problem. So I don't really have much else to say unless you guys think I made a mistake. But yeah, what do you guys think?
Looks pretty good to me.
That looks pretty good to me as well.
Okay. Well, that's all I got to say.
All right.